So let's look at some examples out of 3.6 dealing with functions and things of that nature. So the first question we're going to look at asks for what is the domain and what is the range. So remember that domain are the x values, range are the y values. So if we look at our particular set of points, these are individual ordered pairs. This one has an x of 3, 4, -1, and 2. So if we have individual points, we list their individual x values, 3, 4, -1, and 2, and we put those in braces. If you would like, you could put those in order, but it's not completely necessary. You could call that -1, 2, 3, 4, and that would be fine also. The range is the y values. So we just go through each ordered pair and write down the y value. We have a 2, we have a -1, we have another 2, but 2 has already been included. We don't have to write it each time. The range just wants to know which values occur, not how often do they occur. So we don't have to write another 2, but we have a 7. So that's our range. So just what are the x's, what are the y's? Same thing here. If we look at these, if we want to list the domain and the range, for the domain, those are the x's, and if you ever get that backwards, domain comes before range alphabetically, x comes before y. So the domain is made up of a 2, a 1, a 3, and a 1. But we've already written a 1, so we don't have to write it twice. The range is made up of a 5, a 2, a 1, and a 9. So those are all of the y values. Now, some of the questions just ask for the domain and range, and some of them ask, is it a function or not? So remember, to be a function, each x only goes to one y. So if we look at the x values, the domain, 3 only goes to 2. 4 only goes to -1. -1 only goes to 2, and 2 only goes to 7. So this one is a function. Even though the number 2 is written twice in the range and the y values, that's okay. A y value can be repeated, but an x value can only occur one time. Now, if we look at this one, we have a 1 going to a 2. We have a 1 also going to a 9. So if one x value relates to two different y's, it's not a function. So that one's not a function. Okay, then they give us some graphs and ask us, are they functions or not? And this deals with the vertical line test. So if we draw a vertical line, every vertical line is going to touch at most one point. That vertical line only touches one point at a time. That means every x value has at most one point. When x is -2, there's 1 point. When x is 1, there's 1 point. When x is 4, there's 1 point. So each x has only one y, so that is a function. While we're here, let's go ahead and list the domain and the range. So the domain, remember, those are the x values. So if we start on the left side, the first x value we come to is -4. If we move from left to right, the next point we come to has an x value of -2. As we move to the right some more, the next point we come to has an x value of 1. And then an x value of 3. then 4, then 5, then 7. So that's the domain. We have points at each of those x values. Now for the range, we list each y value. So let's start at the bottom as we work our way up. The first y value that has a point is -1. The next y value that has a point is 1. See, there are points here with a y value of 1. As we work our way up, the next time we have points are here. Those have y values of 3. As we go up farther, we have a point when y is 4, and then 5. So we have points at each of those y values. Down here, up here, 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 up, here, and here. So each of those y values, -1, 1, 3, 4, and 5, we have points. If we look at the next one, let's determine whether or not it's a function. If we move our vertical line, we touch one point here, but notice here, our vertical line touches two different points. When x is 2, this x value goes to a 4 and a 5. When x is 2, it goes to 4. When x is 2, it goes to 5. So this one is not a function. Even though at the other points it only touches once, at this one it touches twice, so it's not a function. So let's list the domain and the range. Again, since it's individual points, we're going to put them in braces. So for the domain, those are the x's. So as we go from left to right, the first point has an x value of 1. As we go from left to right, the next points have an x value of 2. The next point we come to has an x value of 4. The next point we come to has an x value of 6. Then 9, then 10. So we have points at this x value, this one, this one, this one, this one, and that one. So those are the x values that have points. Now if we look at what y values have points, we have points at this y value, this one, this one, this one, this one, and this one. I have a point here, 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 here. So we just need to list each of those y values. So 3, 4, 5, 6, 7, 8. We don't have any points in between 3 and 4. We don't have a point at 3.2, at 3.9. We only have points exactly when x is 3, exactly, or when y is 3, when y is 4, and so forth. So that's our range. Now here they ask for, is this a function or not? And if we were to draw vertical lines, every vertical line is going to touch at most one point. So this one is a function. If we want to do the domain and range, the domain is the x's. And if we look and say, how far to the left does this graph go? Since this is going up and over, this is going to go over forever. The arrow means it keeps on going and going and going. So in the x direction, it goes to the left forever, and also to the right forever. We touch every single x value from left side to right side. Notice if we follow the graph, we're not ever picking up our stylus or our pen or pencil or whatever. So we can't list each individual value. So the domain is everything going from -infinity to infinity. So the way we write that as an interval is we say it starts way out at -infinity, it goes all the way to infinity, and it includes everything in between. So that's what intervals do. We list where they start, where they stop, and it means they include everything in the middle. Now for the range, and let me put a point here so this actually touches there. The range is the y values. So the lowest y value we're at is 0. And then when do the y values stop? Well, they go to infinity. It starts at 0 and goes up to infinity. We have a point here, so we include that. If we don't include it, we put a parenthesis, but if we do include it, we put a bracket. And we always put a parenthesis at infinity. So we include every value starting at 0 and going to infinity. Here, this is not a function. If we were to draw a vertical line there, it touches more than one point. So that's not a function. We won't worry about the domain and range on it. This question asks, is this a function? And the easiest way to see, I guess, is to start out making a table. If we put in a 1 for x, y is 1 plus 5. And that's the only answer we get when we plug a 1 in. We don't have two different answers for that x. If we plug in a 3, 3 plus 5 is 8, and only 8. So when we plug in that number, we only get one answer. And that's going to be true no matter what we plug in. Any number we plug in, when we add 5 to it, there's only going to be one answer. So if each x only has one y that goes with it, it is a function. This one is a little bit trickier, but this equation says y is 2. X can be any number as long as y is 2. But each x is only used one, even though the y's are used for lots and lots and lots of times. Each x only occurs once. So in that case, this is a function. But this one, it looks almost the same, but this says x is always 7. Y can be any number as long as x is 7. So in that case, we have more than one y going to the same x. So that makes it not a function. Here, let's just look at function notation. So if we're given this function and we're asked to find these values, this just means put this number in to this function everywhere we have our input. So f of -3 comes from replacing the x value with what's in parentheses. So anytime we plug into a formula, we want to put a parenthesis around the number. So we put a -3 around the x. 5 times x is -3. So order of operation, we multiply, and then we subtract. So f of -3 is -16. That's an ordered pair. When x is -3, that corresponds to -16. So the answer is -16. So this is an x, the answer is the y. If we're asked to do f of 0, then we take the same function, and where we have an x, we put a 0 in. So 5 times 0 is 0 minus 1. 0 minus 1 is -1. So when x is 0, y is -1. Let's do this one. Let's do g of -3. So if we replace x with a -3, make sure we put a parenthesis around our input. So we do an exponent first. So negative 3 squared, that's negative 3 times negative 3, which is 9. 2 times 9 is 18, plus 4 is 22. So when x is negative 3, we get 22. Now if we do g of 2, where we have an x, we put a 2 in. 2 squared is 4. 2 times 4 is 8, plus 4 is 12. So when we put a 2 in, we get a 12. So that's function notation. This is our formula. This tells us our input. This tells us the name of our function. Here they give us a function and they ask us for the domain of that function. So if we look at this, we can plug in any number for x and get an answer. Any number you pick, you can always add something to it. So in this case, our domain is all real numbers, any number, or we could call that negative infinity to positive infinity. Any number can have 9 added to it. But if we look at one like this, we run into some areas, or an area we have to be careful. When we have a fraction, it's okay to have a 0 on top, but we can't have a 0 on bottom. A 0 on bottom makes us undefined. Even if you take a calculator and try to take something and divide by 0, it tells us, hey, you can't do that. That's not allowed. So any number that we plug in for x, it has to make the denominator something that's not 0. So we want to find out, well, when is the denominator 0? Because that number we can't use. Any other number is okay. So if we add 4 to both sides, the number that makes our denominator 0 is 4. 4 minus 4 is 0. So 4, when x is 4, that's when the bottom is 0. And we can't have that. It's not okay to divide by 0. So that number is not in the domain. So the domain is all real numbers except x cannot be 4. If we put that on a number line, then at 4, we wouldn't include it, but we could have anything to the left of 4, anything to the right of 4. So every number except 4. As an interval, this is 2 different intervals. The first one goes left forever, so to negative infinity. And it gets close to 4, and the way we show it gets close to 4 and doesn't touch it is we put a parenthesis. And then this interval starts really close to 4, and it goes to the right to infinity. And if we write 2 different intervals, we put a union in between them. So that's our domain for this one. Basically, every number except 4. This one asks us for the domain. So if we ask how far to the left does this go, it goes to negative infinity. How far to the right, it goes to positive infinity. And since it touches every value in between it, we put it in an interval. So from negative infinity to infinity. For the range, those are the y values. So if we start at the bottom, how far down does this graph go? Well, this arrow tells us it goes down forever. So we start way down at negative infinity, and then we work our way up, and the highest y value we come to is 1. Even though it keeps going over forever, it doesn't keep going up forever. So it goes up to a y value of 1 and doesn't go up anymore. So all the way down to negative infinity, and we stop having points in the y direction when y is 1.